Hey guys, Mr. Bankwork here. In this video, we're going to look at sensitivity analysis. Now we can use differentials to help us estimate change. The differential df equals f prime of x dx has a geometric interpretation. If we think of dx as being delta x, which is the change in x, then we can say the value of df at x equals a is delta L, which is the change in the linear approximation of f. So if f is differentiable at x equals a, then the approximate change in f when x changes from a to a plus dx can be represented by this differential df equals f prime of a dx. Now we're going to have local linearity because the derivative is going to change by very little over very small intervals. And one of those consequences is that over very small intervals, then the ratio of the change in the output compared to the change in the input, delta y over delta x, can be treated as a constant. This is going to give us another interpretation of the derivative as the measure of the sensitivity of the output to small changes in the input value. So sensitivity is an interpretation of the derivative that describes how small changes in an input value will produce changes in the output value. So for small values of delta x, so the change in x, then we can approximate delta y, or the change in y, by saying that delta y is approximately equal to dy dx times that delta x value. So in this example, we're going to look at estimating some change. We know that the radius r of a circle is going to be increasing from an a value of 10 meters to 10.1 meters. And what we're going to do is look at estimating the increase in the circle's area, capital A. And we want to compare our estimate with the true change in the area, and then we'll find the approximation error as well. So in general, we said if we want to find the change in our y value, we can approximate that by finding the derivative of our function. I'm going to call that f prime of a, and we're going to multiply that by the change in the x value. Well, here we're talking about area. So if we think about our area function for a circle, then that's pi r squared. So if we want to find the change in the area, we can approximate that by finding the derivative of our area function at the starting a value and then multiply by the change in the x value. So if we do the derivative of this area function, drop the 2 down as a multiplier, then we can call this 2 pi r, but then we want to multiply by the change in the x value. So filling in what we know in here, we started with a radius of 10. So I'm going to fill that in for the r value, but then we're looking at how much that radius is changing. So going from 10 to 10.1, then it's changing by 0.1 meters. Now, if we're looking at simplifying this down, 10 times 0.1 is really just 1, and if we multiply that by the 2 pi, then that's just going to be 2 pi. So we can approximate the change in the area to be about 2 pi meters squared, and 2 pi is 6.28, so we can say 6.28 meters squared as our approximate change in the area. Now, if we wanted to calculate the true change as opposed to just approximating, what we would have to do was find the area with the 10 meter radius and find the area with the 10.1 meter radius and then do a little subtracting. So if we look at the radius of 10 first, then we would go pi times 10 squared, which would be 100 pi. But then if we want to find the area with the radius of 10.1, well, then we'd have to go pi times 10.1 squared. Now, 10.1 squared is 102.01 pi. So if we're trying to find the true difference in here, we would subtract these. So if I went with 102.01 pi minus 100 pi, then we would end up getting a true change of 2.01 pi. We estimated the change to be about 2 pi, and the true change, the actual change, was 2.01 pi. Now, if we wanted to convert that into a decimal, if we multiplied that out, that would be 6.31 meters squared. So we approximated that the change in our area was going to be 6.28 meters squared, and the true actual change was more like 6.31 meters squared. Now, if we're trying to find the approximation error, then we're going to take the true change in the area, which was 2.01 pi, and we're going to subtract off our approximated change in the area, which is 2 pi. So we can say the approximation error is 0.01 pi meters squared. So because we were using a pretty small change in that x value, we went from 10 meters to 10.1 meters, that gave us a pretty accurate approximation of what the change in the area would be. That's going to be it for this video. Thanks for watching.